So this is a video about a project I've been working on, making a tool to hold the scales to do the cross weights on this little RC car. There's a father and son kind of racing team that, well, now they own a track in Southern California, but they make a lot of nice equipment for their cars, and they made a system to hold their corner weight scales. I copied it about 2 years ago for a friend of mine. Never had much use for one myself until we started racing these cars, and they're so precise and so sensitive to the adjustments on the chassis. You really need a way to set the cross weight, and then also just to know your front to rear bias and your left right, obviously. So I'm just taking some measurements of the car, the wheelbase, the track, and then the overall kind of footprint, so I can figure out what size I want to make this thing. Now I'm in AutoCAD, laying out the overall profile. Is about 1 foot by 2 foot. And then I've got this little square that's about the same width and length as the track and the wheelbase of the chassis. And from those layouts, I was able to come up with these 3 line drawings we can use in the water jet to cut out the pieces. So this first piece here is a piece of aluminum. It's called Mike 6. It's cast and surfaced on both sides, so it's pretty flat and stiff, and it's a good base for this thing I'm calling a scale box. So down in the water jet, it's cutting the holes. This machine uses about 55,000 psi water pressure to propel that garnet. It's almost like a real fine sand. It can cut almost anything. So here I'm just following the nozzle of the machine with these toothpicks. As the part's cut out, keep the part indexed where it should be. You can see there's about a 1/16 gap all the way around the part. And if you let that thing just go where it wants to, it can wind up with no gap on one side and about an 1/8 inch on the other side, and then your part isn't very accurate anymore. But here it turned out pretty good. Now here I got a piece of acrylic. This one's 1/2 inch thick. This one will be used as the middle layer of the scale box, and it's going to locate the scales, side to side, front to back. And it's going to have a couple of grooves or little tunnels cut in it to route the wires to the interface of the scale set. Here's one of the cutouts. You can see that little vein for the wires, and you see how precise that machine is. It's about 30 thousandths thick, a little remnant piece there. And my dad came by to check out the progress on the cutting.
Oh, is that the new phone? Looks like it. All fucked up already.
So this is the last piece. This one's about 1/4 inch thick, and this is going to be the lid of the box. It'll locate the screen. It has little readouts of the scales, and then it'll be a cover to hide the little tunnels for the wires. So I'm just getting those drop pieces out of there so that they don't crash into the nozzle as it comes around. And right there towards the end, it was getting so much water pressure underneath it, and this little part was so light, ended up lifting it out of the water, so I got it out of the way quickly. Here I got the parts cleaned up, all that paper off of them. You can see some of the little areas in the plastic that's kind of frosted looking. That's from as the nozzle is making its way around and it crosses over the slats in the bed of the machine, it'll blow back a little bit of water and sand and kind of sandblast it. For some jobs it's unacceptable, but for this one it's It's alright. I did some experimenting cutting holes in the acrylic and it didn't really like it, so I chose to just cut the holes in the aluminum and tape all the pieces together and then drill through, kind of use the aluminum as a guide and drill through that plastic. Now I'm getting ready to tap the holes in the aluminum for the little screws that are going to hold this thing together. I started off with this, the little hand driver, but it worked so easy I ended up switching to the drill because there was quite a bit of screws or screw holes to thread. Now I got that top layer back in the drill, countersinking the holes for the flathead screws. Kind of testing the fit of all these things. It all lined up pretty good. Here's a close-up of the little screw. And you can see that little tunnel in the middle layer there. You can see how precise that cutting is. So here I'm tapping the holes. There's 3 set screws, 1 in the front and 2 towards the rear in kind of a triangle. And those are going to contact the table or whatever this thing's sitting on. You can adjust the height of those little screws and make sure that this scale box is sitting level. The first one I did, I had 4, and it was just a pain in the ass because it always wants to kind of teeter-totter, so you just got 3 and it's easier to you're just filing the edges and chamfering the holes in the part. And now I'm routering a little chamfer around the openings for the scales. I didn't want any, when this thing's all together, I didn't want them to clamp down on the scale. I wanted it to just kind of float in its place. So I did this just as a little extra insurance on that. You can see how much of a mess that acrylic makes from the router bit. And, I mean, 2 weeks later and that stuff's still lingering. So here I'm just wiping off all the oils and little fingerprints. I got that piece of carbon fiber vinyl wrap that I'll put on the top of this. I'm just carefully unfolding it. You really only got one shot to apply that stuff. And that's just some pledge and a microfiber just to work out any little air bubbles. I did a couple test pieces and found out that the kind of working the edge of the vinyl against that sharp edge of the acrylic with the handle of an X-Acto blade worked pretty good to just trim off the excess. You can see kind of working around that pocket, just stretching out the vinyl a little bit and then working it on that sharp edge of the acrylic. Cut it perfectly to size. So now I'm assembling this thing, installing the scales where they go. They're kind of color-coded with the little readouts on that interface. So it'll tell you the weight on each corner, and then it can calculate the cross weight and then the front to back, side to side percentages. You see I have those little channels for the wires to run down, and then I have those little pockets towards the scales for the rear tires for the slack of the wire to be coiled in. And then there in the middle is that bullseye level. I can adjust those 3 set screws and then dial this thing in until it's sitting level. Now you know it's real when that little plastic film is pulled off. This thing's battery powered, but I'll probably... There's an option to use a power supply, so I'll probably do that. When I first put the car on here, the rear tires had so much camber they weren't contacting the scales. But it's okay because I'm going to make some wheels to use on here. So it'll only contact the scale in the middle of the pad, but for now we're using the tires. And there's the little race car and the scale box all done.